This video is for comparing and scaling problem 2.3. This is going to be the first part of the problem. It's going to cover unit rates. Hopefully you've heard the word unit rate before, but a unit rate is a rate where the second quantity is always 1. Remember, a rate is simply a comparison of two quantities that have different units. Some examples of unit rates would be the cost of gas being $1.95 per gallon. A cell phone company might charge $7.99 per 1 gigabyte of data used. And the speed limit on the highway might be something like 60 miles per 1 hour. All of those rates compare to 1, so they are called unit rates. For any situation, we could solve a proportion and write two different unit rates. So we're going to take a look at this example where I put 17 gallons of gas into my truck for a cost of $33.32. The first unit rate we can come up with is how much it would cost for 1 gallon. So here's a proportion. I know on the left side I have 17 gallons over $33.32. On the right side I want to scale this to 1 gallon and I want to figure out what the price is. So steps to solving proportions, I'm going to draw my arrows from what I know to what I want to know, find my scale factor, in this case it's 1/17, and take that times $33.32 to get that the price of gas is $1.96 per gallon. Another way I could write that is that 1 gallon of gas cost $1.96. The other unit rate I could write in this case is figuring out how many gallons I could get for $1. So again, draw the arrows, find the scale factor. In this case it's 25/833. Multiply that by 17 and I would get that for $1 I could buy approximately 0.51 or 25/459 of a gallon of gas. Now, obviously in most situations there's going to be one example or one unit rate that makes more sense. For us it makes more sense to think about $1.96 per gallon, but it's important to know that we can write them both ways. So here are three examples. Go ahead and set up your proportions and find the unit rate, and then continue on with the video to check your answers. Alright, so number one, ground beef. The price per pound would be $4.59. If Mrs. Bowers drove 455 miles and 13 gallons of gas, she drove 35 miles per gallon. And if 25 oranges cost $5, you could buy 5 oranges per $1. Okay, some simple examples of finding unit rates. Sometimes we need to be able to find a unit rate when we're not simply given a situation, and it may be helpful for us in that case to instead think about the unit rate as the constant rate of change. Typically we can use these words interchangeable. And remember that the constant rate of change is how much the dependent variable changes when the independent variable increases by 1. So let's take a look at this table from the MR Talk phone company from a previous video. And the MR Talk phone company offers a plan where you get 10 gigabytes of data for $99.99 per month. This was the rate table that we came up with to represent the cost for different amounts of gigabytes, and we want to find the unit rate or the constant rate of change. Now, it seems like it would be evident from looking at this table that the unit rate would be $9.99 per 1 gigabyte used, but we need to verify that we have a constant rate of change in this case. And I know we kind of see that from this situation, but we want to make sure that we set up a process for being able to verify whether there's a constant rate of change. So the constant rate of change means that every time the amount of gigabytes in this case increases by 1, the price is going to increase by a constant amount. So we start by seeing that if we go from 1 gigabyte to 2 gigabytes, we've increased by 1, and our price has increased by $9.99. That pattern would need to hold true for the whole entire table in order for there to be a constant rate of change. Notice our next jump is from 2 to 5, so we're actually increasing by 3. So we're hoping that we'll increase the price by $9.99 times 3, since it was 3 gigabytes. And in this case we do. So we could continue on this table and we would see that the pattern would hold. So in this case we would call the $9.99 per gigabyte our unit rate or our constant rate of change. We also took this table and we wrote an equation for it. We got the equation C equals $9.99 G, where C was the cost and G was the amount of gigabytes. And from here we can see that the coefficient in front of the G is going to be our unit rate, the price per 1. So here's a couple examples. Go ahead and see if you can figure out what the CROC, otherwise known as the unit rate, would be in each of these tables. And then continue on the video to check your answers. All right, let's start with this top left one here. Remember, we need to check every time the X goes up, how much does the Y go up? I like to write it right on my table. First, from 1 to 2 is an increase of 1 in the X. From 5 to 11 is an increase of 6 in the Y. Continuing down the pattern, 2 to 3 is an increase of 1 11 to 18 is an increase of 7. That's enough right there for us to say that there's not a constant rate of change. One time I went up by 6, one time I went up by 7. If I continue the pattern, I'll go up by 8. So since that increase in the y value is not constant, this does not have a CROC or a unit rate. Let's take a look at the top right. Once again, I'm going to compare. I'm going up by 1 on the left, and I go up by 3 in the y. Next, I go up by 1 in the x, 3 in the y. Here's where we have to be careful, though. Notice now that we're going from 3 to 5. So we're really jumping 2 in the x, but we're only jumping 3 in the y. Once again, this is not a constant rate because I went from jumping 1 in the x to 3 in the y to 2 in the x and 3 in the y. So really, when I go from 3 to 5 in the x column, I'm actually increasing by like 3 halves each time. So I really have to be careful here. This one does not have a CROC. Let's look down at bottom one. 1 in the x for an increase, 3 in the y for an increase. That pattern holds every time we go down. This would have a CROC of 3. So simple ways here that we can find the unit rate or the CROC by looking at a table. Let's summarize very quickly about unit rates. We learned that a unit rate compares a quantity to 1. We learned that we can write 2 unit rates for any rate or situation. We learned that if we're given a table, the unit rate is the same as the CROC. And to find the CROC, we need to determine if the y value increases the same amount every time the x value increases by 1. And we learned that if we're given an equation, the unit rate is the same as the CROC, which is the coefficient on x.